Electromagnetic induction. Objective: to learn the phenomenon of electromagnetic induction. In 1831, Michael Faraday discovered that magnetic fields can generate an electric current, a phenomenon known as electromagnetic induction. To test his hypothesis that a moving magnetic field can create current, Faraday conducted an experiment during which he tightly coiled a wire around a hollow cylinder. He connected this coil to a galvanometer, a device used for detection of small electrical currents. He then took a bar magnet and placed it in different proximities in relation to the coil. While the magnet sat at rest away from the coil, the needle of the galvanometer showed no deflection towards either side, indicating there was no current flow. But once the magnet moved towards and into the cylinder, the needle moved towards one side, indicating that now there was an electrical current present. But once the magnet was moved towards and into the cylinder, the needle moved towards one side, indicating the current was now flowing in the opposite direction. When the magnet was placed inside the cylinder and remained stationary, the needle did not move. This indicated that once again there was no flow of current. However, when the magnet was moved rapidly back and forth inside the coil, the deflection of the needle was also quite rapid, indicating that the faster the magnet moved, the more current was induced. If the loops in the coil are increased, there will also be an increase in the deflection of the needle, indicating an increase in the voltage. Based on the results of his experiment, Faraday proposed the following. A magnet moving in and out of a coil of wire would induce an electromotive force or EMF. A stationary magnet, whether it is inside or outside the coil, will not induce current. Reversing the direction of the magnet's movement also reverses the current's direction. The magnitude of the current is directly proportional to the number of loops in the coil, strength of the magnet, and the speed of movement of the magnet in the coil. This basic principle of electromagnetic induction that was discovered by Faraday is now used in electric motors, generators, and transformers. Summary: a moving magnet in a coil of wire induced an electromotive force, or EMF, a phenomenon known as electromagnetic induction. The induced voltage in a coil is proportional to the product of the number of loops and rate at which the magnetic field changes within those loops.